This is Ian Smith. He's Head of Innovation at Rock, and he's doing a talk on AI, friendly helper or job-stealing menace. So I'll hand you over to Ian.
It's all right, I've got a different microphone, so I'm good.
Good for the big mic.
Can you hear me?
Yes.
If you can't hear me, shout. There's always one. Hi, so I'm Ian, as you just heard, and I'm the Head of Innovation at Rock. And what that means is that as we're a testing consultancy, I've become very interested in how in where testing might go in the future. Before I joined Rock in October last year, I worked for IBM for like 23 years, so I'm still suffering a bit from the shell shock of going from an epically sized company to really a much smaller one. And one of the things I was involved with at IBM was on various sort of client innovation projects was artificial intelligence and Watson. And we've heard Watson mentioned a few times, which is good. So I'm going to talk to you about what I think is going to happen in terms of AI and testing. And my provocative title there, Friendly Helper or Job Stealing Menace, is really intended to sort of to provoke us to think about what AI can and can't do and what it is and isn't good at. So a couple of weeks ago at Rock we had an event for students as part of our graduate kind of program, and I had to do a 10-minute chat to them about innovation. So it was all blockchain and AI and all that kind of stuff. But I started out by saying to them, there's never been, if I turn my clicker on, that will work better. There's never been a better time to be in the business of software. And I really mean that. And the reason is that there's so much going on that's so exciting. And I kind of have this idea about the different directions that's coming from towards testing. So changing expectations, user expectations have never been higher. End users expect their work applications to be just as good as their ones they use on their phone at home. Changing practices, agile and DevOps and all that kind of good stuff that's coming along that's making software delivery look really different from how it looked before. But of course, what we're trying to talk about today is changing technology, and one of those, and AI, of course, is a big deal in that. So testing, I think, is a really exciting place to be. But we've just got to ask the question: will we be owned with a P by evil robot testers to come and take our jobs? Who knows what this curve is? Anyone? Almost.
Hype curve.
Hype curve, yes. So Gartner, who are a firm of analysts, do this thing where they measure the level of unrealistic expectation that is associated with different technologies. And their 2017 hype cycle, which I have not reproduced because they won't let me, but effectively what you've got there is you've got innovation trigger in the first section, and then you've got the peak of inflated expectations, then you go down into the trough of disillusionment, and then eventually technologies may come out of that and start being valuable. And AI in last year's hype cycle from Gartner was at the very peak, the absolute top of the unrealistic expectations. And then another firm of analysts, Forrester, released recently their predictions for 2018. And their prediction for AI is the honeymoon for AI is over. And what's interesting about those things is it's basically showing that AI is going to have to start being actually useful rather than something that we just talk about or do interesting technology concepts with. One thing I find about AI is that people think it's magic. And I know that if I did a poll and went around this room, nobody here would say AI is actual magic. But I always remember when it was when Watson came along in IBM, maybe in 2011 or 2012, everyone started to see it as being the thing that was going to solve everything. And they thought it was magic. And I always like Arthur C. Clarke's third law, which is to say, in which he said quite some time ago now, that any sufficiently advanced technology is indistinguishable from magic. So what I would like to do is make AI be not magic, so that we can get more of a grip on what it actually is and isn't. And that lets us think about how it might affect us. So AI was always divided, when people talk about it, into two main things. Strong AI, or artificial general intelligence. For some reason I always say those words in the wrong order. Or pure AI, and that is an intelligence that can think for itself like humans do. A machine with consciousness or sentience or a sense of mind. And at the moment I think most people are agreed that's some way off. So this is what we have today, weak AI or narrow AI. And that sounds a bit wussy really by comparison. But actually, it can solve narrow and focused problems. And that's actually really what we need. And this is achieved, broadly speaking, and ignoring all the horrible complexities that come and hit you if you try to zoom in on this, with the technology known as artificial neural networks. And I'm oversimplifying this in a way that would make an expert horrified. So are there any experts in the audience? Oh, damn. Right, no questions. I'm not an expert, so when I start looking at sigmoid curves and matrix calculus and all this kind of vector calculus, my mind melts and I can't really cope with it. But even within this artificial neural network, there's tons of different kinds. So, you know, recurrent neural networks, feed forward, hop field neural networks, convolutional, deep convolutional, and you know I could go on, but I don't need to because the Asimov Institute did it for me. And what they've said here is with new neural network architectures popping up every now and then, it's hard to keep track of them all, and they've given a very handy diagram which you can look at to understand how the nodes kind of are laid out in different types of neural networks. I invite you to visit that website and have a look, and maybe you can be as baffled as I was. But what all these things have in common is that they are heavily reliant on training. Okay, possibly not that exact kind of training. What the training they rely on is basically needs to be fed by a lot of data. So one application of this is classifiers. So in Watson's chatbot framework, which is called Watson Conversation, there's a classifier, and the purpose of it is that when somebody comes to say something or to interact with the chatbot for a purpose, the chatbot is able to classify a wide range of potential inputs into what it was that person's intent was with talking to that chatbot. And what you do is you train the chatbot by coming up with all the different ways you can think of, and if you've got data from other places, all the kinds of things that people might say to express this intent that you want to help them with, and then you train it with that information, and you hope that your users are not more imaginative than you and can come up with new and exciting ways to say it that your chatbot doesn't understand. So here's an example of a classifier for pictures. There is a Watson for this. So what I've done here is just said, okay, there's a bunch of pictures, and I've tagged them either cat or not cat. And hopefully by looking quickly at that, you'll be able to distinguish between why I've applied those tags to each picture. And then what you can do once you've trained it with a sufficiently large data set is you can say, here's another picture. What is that? And then it will tell you what it thinks it is based on that training. And a lot of AI and chatbots and picture image recognition, stuff like that, is based on that basic way of working. I am aware of a large pet retailer who are now counting the goldfish in their tanks, which used to be a very annoying manual task, using that Watson image recognition API, having been supplied with lots of pictures of goldfish tanks filled with variable numbers of fish and tagged with how many fish were in the tank. So that's, you know, I have no idea how successful that is, but it seems like a really good application of this kind of thing, because any algorithmic way of trying to count fish in a tank from an image is probably quite hard. There's another thing called a recurrent artificial neural network, which is really good at recognizing patterns in streams of data, like characters or images. So it's so good. This is so good. I'm going to show you some really freaky things now. It's so good that after you've trained, somebody took an ANN, and a recurrent ANN, and trained it on Shakespeare, one character at a time. So it's processing the data one character at a time, not words or anything bigger, just characters, including punctuation. And this guy trained this recurrent neural network with the works of Shakespeare, and then it was able to write Shakespeare. We've never been closer to the 1,000,000 chimpanzees and the 1,000,000 typewriters. I mean, I'm not an actor, so I can't really do this justice. It's actually gibberish, but it's quite convincingly Shakespearean gibberish, I would argue. But imagine if we could train a recurrent neural network to read log files. And once it's read the log file, then you tell it which log sequences resulted in crashes. Would it be able to predict when those crashes were going to occur? Well, I think people are doing things like that already with it. So, you know, this is a bit facetious, but actually really interesting. And Google's DeepMind did this amazing thing. There's another kind of thing which I'll talk about. This is an example of, which is a generative adversarial networks, and that's another thing that people are doing. But Google's DeepMind did a thing called AlphaGo, which was a Go playing computer. And some people thought that Go was going to be, I'll show you this animation from their website in a second. But a lot of people thought Go would never be solved for computer playing because it's got so many possible combinations. It's a 19 times 19 grid where you put the pieces, the stones, on the intersections, and the number of possible combinations of that means that you can never, it's more than the atoms in the universe. It's really astronomical numbers. But what they did was they used historical Go games to train a neural network, and they got it to the point where it could beat the world champion in 2015. And then they did more work on it, and they got it to defeat the new world champion in 2016 or early 17. And then they threw that approach out, and they got two networks, and they got them to play Go against each other with no training data at all, except for just the rules of the game. And this animation, I'm just going to show you this. This is what happened. So on 0 days, got no prior knowledge of the game. And after 3 days, it gets to the point where it can beat the world champion of 2015. Oh, sorry, 2016. The years are very confusing. And then after 21 days, it's beating the one that more recently beat the new world champion in 2017. And after 40 days, it's basically the best Go player in the universe. And what's interesting about that is, because it was not trained on any human games, all the patterns of playing that game that have been developed over centuries, it's a really, really old game coming from China, all those patterns and ways of moves and traditions of play that have happened since that time, it's gone to first principles. It's playing Go like a space alien that has had no recognition of all that tradition. It's an incredible achievement, and it's completely got round the need for training data. So this idea of generative adversarial networks is kind of related to this. And that is where you have two networks, and one is a generator and the other is an evaluator. And if you imagine them, one is like a forger and the other one is like a policeman. And so the generator forges stuff, The policeman evaluates it and tries to figure out whether it's a forgery or not. And if it is, it gives feedback, which actually, that's where the analogy breaks down, because policemen aren't well known for giving feedback to forgers on how to get better. And so what happens is they go around in a loop doing this. The generator, or the forger, generates better candidates, and the evaluator, or the policeman, gets better at detecting fakes. And the reason I'm telling you about this is because this is the thing that freaked me out completely. This, does anyone recognise who this is? Okay, this is a person who has never existed. Somebody trained a generative adversarial network with 30,000 pictures of celebrities, and then the generator forged pictures of celebrities. And it started off with random pixels and slowly got better. And this picture is generated by a neural network attempting to forge pictures of celebrities. And here's some more. And there's a video, NVIDIA Research did this. There's those people are not real people. And there's a YouTube video, that's the YouTube video, where you can actually see some of the early in-progress stuff. I mean, I just stole the pictures from it. So I guess what I'm really getting at here is some of these technologies are absolutely, really quite surprising in what they can do. And a generative adversarial network, I mean, imagine if you had a generator that generated code and the evaluator that tested it. I don't know if anyone's trying to do that. I've not read anything, but some of these things are quite hard to Google for without finding loads of irrelevant results. I'm sure they'll fix that when they get their own AI focused onto that. But so some of this stuff's incredible. But what about testing? Because obviously that is the thing we're all here to talk about. And I am kind of, when you Google and try and look around at the various stuff that's going on, what you start to see is a lot of things designed to help automation and to help automation of UI tests. So this is test.ai. That's their website. Actually, their website is very plain, so I had to scroll down a bit to make it interesting enough to put up there. But this is a service that you upload your mobile app to it, and it basically explores the app. And then when you put in version 1.1, it tells you all the differences. And the AI part of it is partly to do with that exploration and finding the pathways through the app, and partly to do with figuring out whether the thing that's changed is intentional or whether it's a defect. Which, you know, that's quite useful, because something that can detect a big list of changes is useful, but then you have to evaluate the list of changes at enormous length. So, you know, you can see that's quite a useful sort of feature. Has anyone used that? Damn, I want to find someone who's used it so they can tell me if it worked or not. So this is Applitools Eyes, and I know this has been around a bit, but but now they've put a lot of more machine learning into it, and now what they've done is they've added into it AI that can figure out whether not that there is a difference between the two screenshots, the one of the image, the system under test, and the one of how it should be. But it can actually figure out where those differences could be perceptible by humans or not. So again, that seems quite useful. And then the final sort of one I want to talk about in this sort of list is eggplant.ai. Is anyone any eggplant users here? No? Okay. So again, they're putting AI into looking at, I mean, they're talking about automating test case creation. So that's, again, more about exploring apps and figuring out where bugs might be. So I think this, you know, this one's probably the most interesting to me of the three. But when I go back to this, which is has anyone seen this before? I mean, no, you haven't, because I drew it, but yeah, the concept. All right, Ian, stop being a smart ass. What we learn, what the point of this, the learning from this is actually you spend all your time automating putting in automation for UI testing. And actually, that's the wrong approach. And what you should be doing is putting a lot more automation of unit tests, a lot more automated system, as you go up, and then that leaves you with a certain amount of manual testing at the top there. But the reason I put this up there is because all these people are focusing on UI test automation. And my question is, given what we learned about that, is that really the right place to focus? But I think that what's really important in terms of moving forward with this is actually data. And we have, in testing, we can potentially generate a lot of data. So, I mean, defects, logs and tickets. I mean, the logs can be logs of automated tests running. They can be production usage of applications. And you can imagine that you can train AI to be able to use this data to add focus to testing activities, figure out where users are actually using the application, which bits are they actually using the most, where's the most value in putting limited testing resource. And you can even use that to prioritize what to automate or even what to build. Optimating. I'm going to make up new words every 5 minutes for the rest of this talk. Optimizing test case design. And you kind of look at combinatorial testing, which people talk about, where you come up with every possible combination and then you have to find algorithms to narrow that down. But again, with historic data, AI would be able to do that. And you could start keeping track of test cases that aren't being executed in particular timeframes or aren't linked to requirements or maybe there are requirements. There's a lot of stuff there in the data of testing where AI could add a lot of value. And at the moment, I haven't seen a tremendous amount. If you Google for what people are doing with AI, in testing, you don't see an awful lot of this yet. But I think this is where I see this as more valuable to testers than necessarily more and more clever ways to do UI testing. But one thing I would say, to get ready for this, start generating the data. And capture as much data as you can from all your testing cycles and store it and save it and don't clear it out. Because when these things come along, the more data you've got to give them, the more benefit you'll be able to get out of them and more quickly. So one of the things that we've been doing at Rock is we actually, I mean, you may notice Watson being mentioned again here. That is my fault. It's just the one I know about. But we got some defects we got basically the defects for a project and exported them into Excel and then uploaded them into IBM Watson Analytics, which is partly a traditional analytics package that sort of looks for patterns and makes sense of data, and partly it's got this kind of AI overlay that means it's quite good at recommending what questions to ask your data, what things you might find you can get answers for. And I'd like to say, and we've revolutionised the world, and nothing will ever be the same again, but it wasn't quite like that. But it was, as an experiment, it was interesting. And we did see some patterns in the data that we weren't expecting. And you can kind of start seeing, oh, OK, so these testers were better at finding these kinds of bugs, for example. And you can't rush into that and say, well, OK, so let's fire them all then because they didn't find the right kind of bugs. Because they were testing different bits of code. And, so you've got to be a bit cautious about what you read into these things. But it was interesting, and it shows some potential. And I think what we can get out of our data will be what becomes interesting here. I've actually got no idea how long I've been whittering on for, but nobody's making any throat-cutting mechanisms to me. So, mechanisms? That's not even a made-up word, it's just wrong. Nobody's making any throat-cutting motions to me, so I shall keep going. So what I thought would be an interesting thing to do would be to ask you, what's the most interesting part, and this is addressed to the testers in the audience, what do you find to be the most interesting parts of your job? Just shout some out.
Finding defects.
Yep.
Automation.
Automation. Any more? I heard something very quiet from over there.
Exploring.
Exploring. Brilliant. Yes. And then if I were to ask you the opposite question, what are the most boring parts of your job? There's more. And the reason I've asked these two questions is not necessarily to find out the answer, but because my suspicion is that actually, if you look at the things that can potentially be automated with AI, it's mostly the boring things. And I guess, I think that giving the boring stuff to these guys is actually fine, because there's a load of stuff that they just can't do. Anything that relies on empathy, or ethical judgment, or creativity, or exploration, or understanding, or analysis, or the application of knowledge, those things will probably, at least for the foreseeable future, be performed better by humans. And if you think about those qualities I just listed out, most of them, if not all of them, are an essential part of being a tester. And I absolutely, what I think is going to happen is that testing everything that can be automated is going to be automated. I've probably said this later and I'm going to be regretting saying it now, but I don't care. What's left will be the stuff that can't be automated, the things that only humans can do. And that's going to be much more interesting, and that will get rid of a lot of the boring stuff. So I don't think we need to panic about the robots coming, although if they start stealing our beer like that one is, I might have to have some words. But you know, that being said, it's my favourite GIF, the future is coming fast. I'll leave that there until you all feel seasick. There's a great quote that was never said by Charles Darwin, and that is, he didn't say this. As soon as you Google it, you find out he didn't say it. I mean, I'm gutted. One day, one of these quotes will actually have been said by the person. But I think it's informative and interesting, and it's not the strongest of the species that survives, nor the most intelligent, but the one most adaptable to change. And I think that, you know, that's our challenge. And things will change. We will, as time goes forward, you know, AI is going to start doing things that humans did before. But ultimately, there's a lot of stuff it just can't do. And I think that's where, you know, that's where we will always have the edge. So that's me. Thank you very much. My slide doesn't say any questions, but are there any?
As AI has killed its first person this week, do you see any form of regulation creeping in to govern artificial intelligence, either by government or self-regulatory, or even Asimov's 3 laws of robotics being implemented? I really love Asimov's 3 laws of robotics, and I always want to put them in all talks about AI, but I thought I'll be here all night if I put in all the things I want to put in. That being said, it's really quite interesting that there are quite a few industry bodies coming along now that are trying to govern how we do this. I mean, IBM, being IBM, did its own thing, so it published like 5 principles, one of which, interestingly, was transparency. And what that was about was people need to always know when they're talking to an AI rather than a human. But there was a meeting somewhere called Asilomar. I still don't really know where that is, except it's somewhere, well, clearly it's somewhere. There was a big industry kind of shebang there where people got together to put down some guidelines and principles about how to implement AI. And there was a whole bit in there about let's not have AI weapons that go mad and, you know, take over the world. Or there was some stuff in there where you're reading it thinking, well, that's a good idea. You know, let's hope it'd be nice not to have AI weapons that can. Well, I mean, it's just frightening. The point I suppose I'm making is at the moment there are people regulating stuff, but they're not the lawmakers at the moment. They're the industry, and so if they get it right and the adoption is right, then there may be no need to go beyond that. But that being said, yeah, I think if that doesn't happen, then the governments will get involved with it, and it will probably be heavy-handed and awkward. But the other thing to say about that is that I think the injuries and fatalities per million miles on the road are a lot lower for self-driving cars than they are for human-driven cars. And I think that
actually this is the answer to that problem and not a cause of it. So, yeah, that's just my opinion. Great question, thank you.
Thought you'd appreciate it.
I'll pay you later.
Do you have a view on a paper that I read very recently? It came out from the Harvard Business Review in late February this year. And it was to do with AI and the changing jobs market especially. And they put forward 5 particular viewpoints. 1, dystopian, everything's going to hell in a handcart. 1, utopian, that everything's going to be super, super duper and everyone's going to be super wealthy at the end of it. Technology skeptic, which is kind of like, oh, we'll get the technology in, but we're not that sure we trust it. I know the 2 categories, I can't remember offhand, but if you happen to see that, do you have any viewpoint as to what kind of direction that future will bring us?
I didn't see it, but I have my whole life been a technology optimist. I've always liked technology, and I've always been an early adopter of stuff. So I feel positive. I think that there are some things that could go. There are ways in which the wheels could come off. You know, we were just chatting about actually, you know, that idea of deploying chatbots to do trolling, for example. You know, that technology. I mean, if IBM found people using Watson for that, they would just turn it off and not let them. You know, they would stop them, or they would try. But you know, there's this technology is out there, and people will find, you know, bad uses for it. So I guess it's one of these evils like surveillance. You know, I know I sound like a dystopian, don't I? I like technology, and I want it all to come out nice. Is that just evading the question? I think it might be.
Well, in relation to the jobs market, you were saying about the job stealing effect.
Yeah.
That's why I mentioned the review.
I think there are things that only humans can do at the moment, and for the foreseeable. And so only a human can have empathy with an end user, and be able to view the application through that lens. And that's why I think jobs will change, and a lot of things will disappear. I mean, there is a, you know, driving as a profession seems to be doomed over the next 10 years. But generally, when that's happened, there's been some kind of balancing effect. I guess, yeah, I'm just talking really, aren't I? I think we should have universal basic incomes to cushion against that. I think it will take governments a long time to come around to that view, and there may be quite a lot of pain in the interim. That's what I think.
So I've got a question. So at the moment, is it possible for AI to check your code to see whether this is good quality code or bad quality? Because, you know, nowadays we use a lot of code metrics to give you some code smell inside of your code. But that is more like, you know, it tells you it's probably something is not right in your code. But can AI give you more insight into your code?
Very possibly. So one thing you can imagine being able to do is train AI with lots of code and say this was good and this is bad. And if you do that, then once you've done enough of it, you can imagine an AI being able to have enough understanding to at least express an opinion about it. That Shakespeare example, which I thankfully resisted reading out in some kind of fake Shakespearean actor voice, that guy went on to put the Linux source code into that network, and it was able to produce stuff that looked convincingly like Linux source code. And I think if they trained it with enough of it, it would probably get to the point where it would be able to compile. But what it would do, I mean, it's just random. It's just so good at identifying the patterns in it that it can put it. So it does the whole header, includes a few random include files. It's absolutely incredible, actually. It's kind of a bit, you're looking at it thinking, wow, I mean, if I'm not I've had a technical background and I can read C, but I'm looking at thinking, oh, if someone gave this to me and said this is part of the Linux kernel, I would look at it and I wouldn't say, no, it's not. Someone much cleverer than me, who had more experience with that, would be able to do that. But that's kind of given me, that's kind of undermined my my ability to think that that's too hard for AI at the moment. I might have been more sceptical before I'd seen that.
I think my real question is probably when we talk, for example, if we talk through a chatbot with AI system, do they really understand us? So that's my no. So that means even AI system can evaluate whether our code is good or bad, but they wouldn't be able to understand what we are trying to do inside the code.
Exactly so.
Right. Okay.
It's when you're if you think about that chatbot example, all that we're doing is training it with in the Watson conversation chatbot, you've got three main things you have to build. There's intents, entities, and dialogues. And entities I will skip over because of the point I'm trying to make. Dialogues is a structured conversation about a thing. And intent is, here are the things that you want that this chatbot will do for people. So let's say it was an IT help desk chatbot. Maybe an intent for it would be, my account is locked. And so what happens is you come along and you say, my account is locked, or you say something like that, and they will have trained that chatbot with every possible way they can think of, and hopefully some ways that people actually use in the real world as well, where they say, my account is locked. And they may be describing what it's like to try and sign into a locked account. They may not have identified what that problem is. So you train it. And then when you come and type in, my account is locked, Watson Conversation says, aha, I believe with a 74% confidence that this input relates to this intent. And then you can have code there that's basically saying, if the confidence is less than 50%, then I don't know what you mean. I know about the following things. If it's greater than 80%, then you're pretty damn sure. And then you just go into the dialogue for that. So the dialogue for that will say, what account is it? What's your username? What system is the account on? Take you through a conversation and then use robotic process automation in the back end to unlock the account. But it doesn't understand at all. All it's doing is it's got this load of training data and it's just trying to figure out what does this look most like. But the thing that's special about it is that it's really quite good at that. Much better at that than if you try to do it algorithmically, by writing code that look for keywords or however you might do that.
A lot of human skills aren't a million miles away from that. I mean, if you throw somebody an apple, they catch it without knowing calculus.
Yeah.
So.
It's not really a question, but surely that description is the same as a new employee. They've gone through a training process, they try to learn the terms of what they do as a human. Everything you said there could be applied to somebody just starting in a new company.
I kind of get where you're coming from, but I would say that when you let's say you were going to train someone to operate as a help desk agent, you would talk to them about when their account is locked out, here's what you do. But you wouldn't have to say, here are 400 ways in which people say, my account is locked out.
Because they've had previous training data there.
Are you making the motions now?
I'm making that. Oh, it's been the last question, but it's all okay, face.
That's incredibly expressive. I admire your facial dexterity to do that. No, I get.
That's not a question.
I get what you're saying, and I think there is. What my advice is, go to IBM's website, IBM's cloud website, sign up for an account, and have a play with training a Watson Conversation bot, because actually you can do all of those things I just said for free, and you will learn. I guess you'll get more insight into what it's like to do that by that exercise than listening to me wittering on for even another hour. I'm just looking to see how horrified Amy looks when I say that, but she wasn't listening, so she didn't.
Always listening.
I'm done.
We've got one more question.
One more question.
Yeah.
Where
Where does AI stand with the law in terms of determining the case in particular?
So the question was, in case people over here couldn't hear it, was where does AI stand with regard to the law in kind of determining, I guess you're saying, responsibility for things?
So determining which case, which side of the case will win. So if you had common law, for example, you can use precedents to determine.
Oh, you're talking about the application of AI in the field of law.
Yeah.
Oh, well, that's an interesting one because they're already doing it.
Are they?
There's actually a bit of a problem because the very large law firms are all putting in AI stuff now to read all of that case law, all of the legal precedents, acts of parliament, all this kind of stuff, so that they can answer questions about it, which kind of undermines the purpose of junior lawyers in those firms. And unfortunately, the only way to get senior lawyers in those firms is to start by having a lot of junior lawyers. So they're a bit worried about it. And the other thing is that senior lawyers don't get billed very much because they have an organisation of junior lawyers underneath them who make all the money that they earn. And unfortunately, if you get rid of all the junior lawyers to an AI system, that spoils their billing numbers. So I think they're very interested in all of this, but I don't think they're quite certain how it should pan out. Are you going to come march me off now? Come on, man.